In this example, I want to find f of 2. I'm going to use synthetic division, and my function is f of x equals x cubed minus 7x plus 6. So I'm going to evaluate this. I'm going to use synthetic division. So we go ahead, create our chart. Notice I don't have an x squared term, right? I skipped from x cubed down to x. So I'm missing my x squared term. So I have to be very, very careful and take that into account. So when I write down the coefficients, I have 1 and then I have a 0, right? Because I'm thinking of that as 0x squared. But I need to represent it in the process. So it's represented with this 0. And then I have minus 7, and then I have 6. And I'm going to evaluate at 2. Okay? So there we go. So we've set up the chart. We were very careful to note that we were missing a term, and we represent that missing term with a 0. And now we're ready to perform the synthetic division process. First thing we do, we want to bring down the 1. And then I'm going to multiply 2 times 1 and put that here. And then I'm going to add down. So 0 plus 2 is 2. And then 2 times 2 goes here. So that's 4. And then I add down. So negative 7 plus 4 is a negative 3. 2 times negative 3 goes here. So I have negative 6. And then when I add down, what happens? I actually get 0. And that's big. We've actually found a 0. So x equal 2 is a 0 of this function. And that's big because that means it's an x-intercept, right? So if we were going to graph, that means that x equal 2 is an x-intercept since it's a 0. So that's big news. More than that, since we have a 0, what that means is that if I divide x cubed minus 7x plus 6 by x minus 2, it divides evenly. Not only that, so we get a lot of information. When we have a 0, we get a lot of information. So x cubed minus 7x plus 6 is actually x minus 2. Okay, 2 is our 0. And then, so it's x minus 2 times, and then the bottom row here, these are the coefficients of what goes in parentheses. So it's going to be 1 times x squared, so it has degree 1 less, right? We started with cube, so now we're degree 2, plus 2x squared minus 3. So that's big news. Whenever we have a 0, not only do we know we have an x-intercept, but the synthetic division process actually tells us how to start the factoring of our polynomial. So x cubed minus 7x plus 6 will be x minus 2 times x squared plus 2x squared minus 3, which, side note, we can continue to factor, right? X minus 2, I can factor that. I get, let's see, 3, 1, so that would have to be plus, and that would be minus. So having that extra information, knowing that x minus 2 is a factor of our original polynomial, and then knowing the other factor based on synthetic division, we can look at that other factor, and then we can factor that on our own, and we have now come up with the factoring for our original polynomial function. And that's good. That's big news because we can use that to graph. We can use it to find the other zeros, but that's great information to have. And we got it from recognizing that when we get a 0 through the synthetic division process, these numbers, the numbers in this row right here, have a big meaning. Those are the coefficients of the other factor.